Okay, we have another word problem here, this one on radioactive decay. The half-life of cesium-137 is 30 years. That is the half-life of this element cesium. So it can be modeled by the equation. Hey, I'm going to need this equation where A is some future amount of cesium equals A sub 0, we'll call that A naught, times 1/2 raised to the T over 30, 30 being the half-life, where A is the amount after T years. Again, A is the future amount, A naught is the initial amount, and T is the time in years if we start with a sample of 10 grams. So this tells me here that 10 grams is my A naught, my initial amount. Okay, so my initial amount is 10 grams. How much of the sample remains after 80 years? 80 years will be my T. And if my half-life is 30 years, I'm going to have a whole lot less of this stuff left, because after 80 years I will have experienced 30 2 times over. I would have 2 half-lives. So I should have less than a quarter of this remaining. So let's see what happens. So A equals A naught, which is my initial amount, T, times 1/2, or 0.5, raised to the power of 80, being T, divided by 30. So 80 over 30. Since I'm solving for A, I can just calculate or key punch this one and see what happens. So here we go. 10 times 1/2, or again 0.5, raised to the power of 80 divided by 30. And enter. 1.57. So 1.57 grams. And I want to put my units on there. 1.57 grams. Does that make sense? Well, let's think about it. I started off with 10 grams at period 0. That gave me 10 grams at period 0. 30 years later, I've executed one half-life. I would have half of that left, which would be 5. Another 30 years later, it would be 60 years. Another half-life executes, and that gives me 2.5. And then we get down to 80 here, and that's going to be 1.57. Hey, this answer makes sense. So now I want to write a little sentence, and we'll do that now. To write a little sentence to justify my answer, I'll just simply say, in 80 years, there will be 1.57 grams of cesium remaining. There we go. All done. Part B. After how long will only 2 grams of the sample remain? So right here, how long means that I'm solving for time. So this is different. And I want to know when will only 2 grams remain. So when will only 2 grams remain? That's my future value, which will be A. So as I put that into my formula, my future value 2 equals 10, my initial amount, times 1/2, raised to the t divided by 30 being my half-life. Again, guys, here I'm solving for this t right here. So before I can do that, I need to isolate my exponential piece. My exponential piece is base raised to an exponent. So I have to get rid of this 10. Divide by 10, divide by 10. That will give me, when I carry this over here, 1/5 or 0.2 equals 1/2 raised to the t divided by 30. Again, to get to my t, which is up here in the exponent position, I have to use the inverse of exponents. So the inverse of exponentials is logs. I'm going to get rid of the base of 1/2. So I'm going to go log base 1/2 of 1/2. Those will cancel and leave me just the exponent. So on the right side here, if I can get it to arrow down, on the right side here, this will cancel off and leave me with t divided by 30. And on the left side, when I went log base 1/2, I've got to do the same thing over here. So log base 1/2 of 1/2. When I write that into change of base form, it'll be log of the argument. So it'll be log 1/5 over log of the base. Almost finished. To solve for t, t is being divided by 30, so to get rid of that, we're going to multiply by 30. That'll clear out that denominator and give me t all by itself over here. What I do to one side, I do to the other. And now I have isolated my t, and t equals this. I'm going to do my log work first and then multiply by 30. So let's put this into our calculator. So my logs, I have log 1/5, which is 1 divided by 5, over log 1/2, 1 divided by 2, hit enter, get 2.32, and then the last thing I have to do is to multiply by 30. So I got 69.657. So 69.66 years. So in 69.66 years. So then I can try to write a nice sentence to sum this up. So my sentence, here we go. In 69.66 years, there will only be 2 grams of cesium remaining. There we go. I hope that helps.